In this video, we're going to be demonstrating using the Flexus Q5 as an HTTP web server and web client and utilizing the JSON HTTP format. Let's go ahead and get started by connecting power to our device. And this also includes network connection since we're using power over Ethernet. And you'll see we've just got an IP address here. Let's go ahead and put that in our web browser, 172.168.220.64. SCADA. So this is the default overview page. You can see the real-time values of each of the 8 analog inputs and the load switches. And if we go down here to switch 1, I turn that on, you'll see it turns on in the interface and turns off, and we can actually change them from here as well. If we turn that on, off, you can see it's sending those commands to the device in real time. And what we're going to do today is we're going to be looking at some of the logic scripting functionality. So for most things, monitoring 4 to 20 milliamp sensors, 0 to 5 volt sensors, 0 to 10 volt sensors, that's all done easily using the built-in scaling calculators. There's no logic scripting or programming required for that. What we're going to look at today is a little bit more advanced. It's when you want extra functionality. So we do have scripting available where you would need additional functionality. Maybe that's conditional relay control. Maybe you want to send data to your own web server. Maybe you want to communicate between multiple devices. Those are areas where you would need logic scripting. And additionally, if you wanted to create calculated values, like maybe calculate your site runtime, those could all be done through logic as well. And there's a whole host of built-in examples. We have lots of examples for everything you might want to do. And in this case, JSON Web Client and JSON Web Server is what we'll be doing today. We won't be using the example, except to refer back to it a little bit throughout the video. So let's go ahead and get started. Let's start off by connecting in battery voltage to channel 1, just so we can see some real data here. So I'm going to unplug the blank connector here, and zoom this video feed out so you guys can see. And I have a pigtail on just a 12 volt battery here. We'll go ahead and connect that into channel 1, and we can see our voltage. And if we go back to our logic page now, let's go ahead and get started. So this is a subset of JavaScript. It's basically strictly typed JavaScript, so it's pretty much JavaScript. We're just going to assume you have somewhat of a basic understanding of JavaScript. Even if any familiarity at all, you'll pick this up very quickly. But we won't be going into JavaScript in too much detail. There are a lot of great resources out there on it, and we have examples here as well that cover kind of our unique functions and whatnot that we would have. So let's go ahead and set up the HTTP server. We'll create a function, http.handle, and then we'll put a function that's going to handle any of the incoming web requests. So let's go ahead and make an inline function request, and return. So that's the value we're going to return. And let's call it battery voltage. If it's 1, instantaneous. And let's do that. Just make our main while loop. And this is important that we don't do just while true. We could just do true in here and it would just run forever, but it would have no way of stopping the script when you wanted to make a script change or anything. So we use the run function, and we'll just put just a wait in there. Everything happens with this callback function, so we really don't need to do anything else. So let's go ahead and test this out. Let's go back over here, 64/. So we can see immediately the web server is responding to our request and it's returning the battery voltage. So that's pretty straightforward. Let's go ahead and do something more with it. Let's move this function handler out of here, so it's not inline function handler, and let's just call it web request. And let's just make that again up here. Up a little bit. Let's response. And let's also add uptime. we go. So let's go ahead and run that. So basically the same, we just have uptime on there that's incrementing up. So let's go ahead and see what we can do with this request object. So this contains any URLs that are requested. Let's print that out. Request. And let's just test that. So now go over here, let's just run that again. You can see in the log. So there is no data sent, no payload, and the URL is just blank. So if we put in slash, say for example, IO, and we refresh this, you can see there the URL is IO. So let's see how we might use that to our advantage to do some things. So let's create a function here, if request IO, or sorry, .url. IO. In this case, we'll return the data that we just did here, and if request.url, let's say it's w1/on. So if it doesn't get handled by any of these request handlers, it'll automatically just print unknown URL. So now let's go ahead and test that. And let's go ahead and bump this down to switch 1. And so if we do IO, you can see our IO endpoint is w1/on. So you can see our switch is on immediately, /off, and it's off. And if we put in a bad URL, unknown URL. So it's super simple. We've just created a web server and we're sending back data and just a few lines of code there. So it's very straightforward. You could be changing this around to suit your application. Maybe that's water levels, maybe it's reservoir levels, it's pump current, energy consumption, it's solar current, it could be turbine RPM, it could be anything there, but we're just showing how easy it is to use the JSON format for exchanging that data. And so let's go ahead and let's make a web client now. So I have another Q5 device here that I've already gone ahead and logged into. We haven't put anything on it here, but let's set up this device to request this data here that we've just made available here. So let's go ahead and look at the examples here. So there is a web client example, and we can just start with that. So this is the URL that we're going to be requesting. So let's put in our .64/. Oh, we're not going to send any data. 1 second timeout, no encryption. Don't even really need that. It's irrelevant for what we're doing. Set up our loop. Again, this is just allows our execution to stop when we need to change configurations. And let's run this every 5 seconds, 5,000 milliseconds. Let's print the response. Okay, let's go ahead and test that. Come over here. See their battery voltage. So it's just made this request here to our 64/IO endpoint. So it's going to be getting the battery voltage and the uptime. So if we look back over here, it's exactly what it's getting. It's getting the uptime, it's getting the battery voltage. But you can see this here has not been formatted. It's just the raw JSON. So we want to convert that into an object that we can actually do something on. So let's look into that. Notice the code there is 200. That indicates a successful response. So if we come over here, we can do if code 200, then we could say that payload object equals JSON.parse Let's go ahead and parse the JSON payload, and let's just go ahead and print that now. Sometimes even I have to refer back to the documentation on some of that little stuff. It is a case-sensitive language, so you just want to make sure you have cases correct. So if we go back here now, you can see it's in its object format again. So you can see battery voltage and uptime. So what we could do with that now is we could say if, or we could even just do, let's just comment that out. We could do print payload battery voltage. I would just print the raw voltage. So very useful functionality. We could also send data to the remote server in this as well. So let's just go ahead and make a little request payload here. Payload equals, let's say, value 1 and time. Just send that down here. So we are going to send a payload there. And so now if we go ahead and test this, go over and look at the server now, and go back to logic here, you can see the server now is getting that data that we just sent up from the client. And so that kind of highlights a really useful functionality where you have a device where you want to actually upload data to your server, like an HTTP post request. So you could formulate a JSON payload and you could send that up to your web server. And there's a lot more functionality here, like you can do custom headers, you could do AES encryption on that. A lot of that's covered in the examples there, but we're just kind of just showing how easy it is to basically take real world data, real sensors, 4 to 20 milliamp, 0 to 5, 0 to 10 volt sensors, battery voltages, you name it, take those analog inputs and convert that into a JSON ready format and send and receive that data with your own servers. So it's especially useful as we have very different equipment manufacturers. So different equipment supports different formats. Maybe you want the device to function as an aggregator where you're reading physical device over, say, serial or RS-45 or CAN bus or some physical Modbus protocol, and you want to send that data to your server, or you want to make that available in a web interface. All that functionality then is super easy to do. There's also the functionality that you can put an SD card in the device, and you could have your own web server files. So you could have like an HMI front end that would actually request the live data from the FlexSCADA Q5, and so you could use the device as kind of its own real-time basically monitoring system. And that's everything today. It concludes our demonstration. If you have any questions, feel free to reach out in the comments section below or on our website flexscada.com. And yeah, I'd love to hear back any feedback. And if you need extra support, as always, feel free to email or phone us anytime. Thanks for watching.